Okay, so it's week 4, and this is essentially lecture 8. I'm going to give 2 lectures per week. And so the question came up, so what does Microsoft Excel have to do with energy storage and distribution? And it's like, why would I need to relearn Excel again? Well, hopefully you know enough Excel already to be dangerous in this course, because if I just threw you into the deep end and said, hey, let's start doing energy storage and distribution without any spreadsheet experience, there'd be trouble. So, that's why we have the CSCI computer modeling, CSCI 172 computer modeling as part of the curriculum. So the question is, what do spreadsheets have to do with energy storage and distribution? And the one quick answer would be that this course could also be called decision theory. And you can even write that down. There's a whole field of decision theory. Like, how do I make decisions? Do I just go and eat the cake right now? Do I save it for later? Do I feed it to the dog? Do I set it on fire? Like, how do I use the resources at my disposal? And so and again, the thing to keep in mind in all of these exercises is that you have in any energy technology, you have to make a decision as to whether I want to spend the money now or spend it later. And that's why we covered financial functions first. And none of these, maybe some people, if you're Rain Man or whatever, you could do those financial functions in your head, but for most of us, it's better to leave that exercise to the computer. So, the next question comes, well, why spend all this time in the computer modeling in Excel? Let's just go out and build things. Well, as it turns out, we already have a great grid out there. Hydro dams are running, nuclear power plants are running, more solar's coming on, more wind. And so the primary purpose of energy storage and distribution, and that was the motivation for that very first exercise, is to put everything in the same common units, put everything into kilowatts. And so, perfect example, I'm not going to go out on Facebook right now, but I'll just mention the fact that there was a person online, maybe I'll just hold it up to the camera. It's entertaining. Let me just see if I can get back to it here. We are in the brave new world of, okay, so here is a picture, wait, let me pull it back up here. Here he is at the top, okay. So there's a picture of a man sitting on a bicycle, and it says, you can exercise for an hour a day and power your home for 24 hours. So, let's look at that.
That's interesting.
Well, so now I can just, so one thing that energy storage and distribution allows us to do is say, gosh, is that statement true or not? So let's just take a look and see how true or false it is. So if we start off, and let's just say energy per day. This is kind of getting back to Energy 101, and we know we're at 2,500 calories, right? That's one human power, and then let's just do calories to joules. What's that? 4,200?
Yeah.
Something like that. So energy per day, this is going to be in joules. So this equals calories times joules. There we go. Control 1. Oh, you like these guys up here. Number, ding, 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 ding. Okay. So there's your joules per day. Yeah, let's do energy per day, and we'll do this in megajoules now. So, and just for completeness, let's just do this, insert. So this is going to be joules to megajoules. So we're looking at 1 E minus 6. Control 1, let's put that in scientific notation. Because there are 1,000,000 joules in a megajoule. So equals energy per day in joules times megajoules. And we'll change that back to just regular old numbers. 11, we'll go with 11. So 11 megajoules per person per day. Okay, so this is a person. Now, here's a house. All right, and this is going to be power. And it's going to be approximately 1 kilowatt in electricity. Let's do this. So this is going to be power electric. And the next one is let's just do power, and this will be heat. Actually, let's take it one step further and let's just say heat ratio, or actually we'll do it the other way around. Heat to elect ratio. And it's usually about a 4 to 1. Usually about 4 times as much, at least in our climate here. And so power and heat, this is going to be in kilowatts. So from here we say equals 1 times 4. And then we're going to power total, and equals the sum of the electric and the heat. Okay, this is also going to be in kilowatts. Save this guy. Let's save as, browse, courses, ETC 214, and we'll just call this human home power. Save. So we've got energy per day, and over here we have power. So let's just turn this into, let's turn it into power. Yeah. So first let's do, let's see, and let's do it again. Energy per day, and let's put this in. I'm going to put it in kilojoules. That'll allow us to get into kilowatts. So kilowatts per megawatt, 1,000. And then energy per day equals the megajoules times the let's do it this way. Let's do it in joules. Kilojoules per megajoule. Same difference, but we're using energy. So energy per day, and this is in kilojoules. Okay, so now let's do seconds per day equals 60 times 60 times 24. That's seconds per day. Use them wisely. And then we'll do average power. And this will be in kilowatts. So equals so power is energy divided by time. Okay, so a human, and again, this is good practice for ETEC 214. 3 significant digits is enough, so there we go with that. Average power, so 12% of a kilowatt. So now we say human powers to run home run the household. Let's say run, not to run home, but to run the household. That equals, so it's going to be this number divided by this number. So you're going to need 41 people pedaling on those bicycles 24/7. So the next one is going to be, so we'll say fudge factor, because they said, we'll just call this, we can even call this the duty cycle.
Okay.
Or the, there was a special word used in the course, it was, it's the amount of time that the device is on. Availability factor.
Availability factor?
Well, I'm blanking on it. Let's just take a quick pause, we'll find it. Because I want to tie it in with the course. Give me one. Okay, so another word for duty cycle is use factor. And that's really what it's looking at, because the advertisement said the man is going to ride his bicycle for 1 hour per day. So the use factor. He is using it for equals 1 divided by 24. So he's using it for 4% of the day. So the fudge factor equals this number divided by this number. So you can see if that number were 1, it would just be the same if you were pedaling it 24/7. So you actually need, so the fudge factor on this is almost 1,000. I mean, so the answer to this question is that in order to do this, I mean, they're actually off by a factor of 1,000. So you would need, 1,000 people for 1 hour every day. Like 1,000 people would have to come to your house, and each one of them pedal for 1 hour to power your house.
Yeah.
And not just for one day, but like forever, every single day. So this is a neat concept, but it's actually off by a factor of 1,000.
You're saying, is he using some sort of perpetual motion?
No, yeah. So I guess what I'm trying to impress upon you, though, Shauna, is that this is one of the main reasons for studying energy storage and distribution. So that when somebody comes up and says, oh, look, I have the answer to the world's energy crisis. We will pedal our ways to salvation.
And then you go, no.
A little bit has to change. So, right, because obviously, I get on this website and I'm like, oh yeah, great, I'm going to buy one right, it's going to work. But and I can't even tell you how many students have come through the doors here saying, and in fact, one student, I love this guy, he said, I'm going to start a business, I'm going to call it Imaginary Dream Machines Incorporated, and I'm going to have bicycles that go 80 miles an hour, and then we won't have to drive our cars. Well, there is a bicycle that went 80 miles per hour once with a very special human being inside, but the point of doing the energy storage and distribution class is that now we can make a quantitative argument and actually make a decision. Would I go and buy this to power my house? No. I mean, might you go and buy it if you had a lot of money and lived in a cabin and wanted to lose some weight and keep the lights on? Yeah, maybe you would. But it's a fun educational exercise is really all it is.
An hour and take a hot shower?
Yeah, I mean that's
You get out.
yeah, that's what it is. So does that answer your question though? Why we do spreadsheets in energy storage and distribution?
Well, the title just doesn't go along with what I'm looking at. I guess.
Oh, I see. Oh, well, so hopefully week 4 will change your mind because now we're going to start to look at electricity bills.
Yeah, now that we're starting to put it towards
Yeah,
everything, so
yeah.
it's just this financial spreadsheet thing.
Yeah.
Because I'm going, I can do spreadsheets.
Right.
Write up a bid.
Yeah, so that's a great question. So what we've done up to now in the course, so week 1, we put numerous different energies into a single currency. the kilowatt hour. That was our first, and that's what I just did here with the kilowatts on the spreadsheet. And then, rather than introduce financial functions at the end of the course, which typically happens in a tech course like this, we just put the money stuff up front so you're thinking about it. Because every single one of these problems is, do I spend money now or do I spend it later? Every single problem is like that, yeah, ROI. And then what we'll see down the road, we're going to start to compare different energy technologies coming online, going offline, demand, supply side, demand side. So these first 3 weeks have just gotten us ready for weeks 4 through 14.
This is just a little prep.
Yeah, and the end goal of this course is not to learn how to use Microsoft Excel. It's merely a tool. Just like we're not teaching English, or it's not, the goal is not to learn English. It's to learn the
How to read.
yeah. It's just how to read the technical language and interpret the technical documents that we're going to be looking at shortly. So, okay, I'm going to leave that as an intro, and I'll come back and do another blurb. But hopefully that is a good Kickstarter here.